It's HYLN video time, and I'm responding to a comment that reads, would you mind comparing the energy density kilowatt per footprint, kilowatt per volume, and or kilowatt per mass between the Carnot and competitors? And I think this is in a response to that Seeking Alpha article. And in the summary, the second paragraph says that HYLN's Carnot generator, a fuel agnostic linear generator, faces competition from mainspring and lacks significant differentiation or unique intellectual property. And I think that comment is kind of guiding me at the lacks significant differentiation, because if it lacks significant differentiation, the energy density should be similar. Let's take a look. One advantage of the Carnot generator is it provides class-leading power density. If you compare the product details of each, Mainspring Energy versus HYLN, Mainspring offers a higher power output of 250 kilowatts versus HYLN's 200 kilowatts. Take that information, put it into a table. You see a side-by-side comparison. To get the footprint, you have to take a look at the physical dimensions. One of us is asking the footprint in kilowatts per square meter. Mainspring, they list the dimensions in imperial dimensions, that's feet and yards, US units of measure, whereas HYLN, the dimensions are in using the international standard of measure in meters. There's also, I'd like to point out, a superscript 4 by dimensions, and it's saying that the final dimensions are subject to change, and it also does not include the dimensions of an optional inverter. So I don't know how large this inverter is or where they're going to put it, but it does not include that, whereas Mainspring, it has an inverter. If I take Mainspring's 20.5 feet by 8.5 feet, and I have to convert those to meters, throw them into a table, and then take HYLN's measurements of length and width, you multiply them, you get the kilowatts per square meter. Mainspring has 15.44. HYLN has 92.59. The higher number is a better number. And it looks like HYLN has significant differentiation from its competitor. It's almost a 500% increase in footprint density. If you're going to take a look at the volume density, and I know that they're not liquids, but if you're going to use the height, you'd have to go to take the height of 9.5 feet for Mainspring and include that. With HYLN, it's a square essentially. Well, it's not a square. It's the height and the length are kind of a square measurement. But you also have to include 2.4 meters. Throw this into a table, multiply everything, and kilowatts per cubic meter for Mainspring, you have 5.33. HYLN is 38.58. Those are not similar numbers, and HYLN has a higher volume density, kilowatt per cubic meter, of approximately, you're looking at a 623% increase in energy density. Now, the advantage that Mainspring has is it actually makes a product and sells a product, and it's actually used, whereas HYLN, I still don't know what's going on. They're taking their suite, they're doing additional testing. But that's the main advantage. And would you rather have something, the question for the customer, would you rather have something that can produce energy now and take up a lot of space, or wait a little bit and have something that can produce energy a little bit later and doesn't take up too much space. Now, I can't compare the kilowatts per weight in kilograms because in HYLN's product specification sheet, they don't list what the weight is in there. That's it for this video. Thanks for watching.